Greetings! Let's do some more calculus. Particularly, I'm going to work with you on u-substitution today. This is a technique in integration for undoing the chain rule. And I think it requires a little bit of practice, and so I wanted to go through another problem with you. So I've got a problem on the board already. And what I'd like you to do is to pause the video and think for a second, or longer, however long it takes you. I want you to try to identify u, where u is the inside function for the method of u-substitution. So go ahead and try to find u. Do you think you found it? I think u is the innermost function, and I'm trying to hunt for a part of the function where the derivative of it appears somewhere else. So a couple of things are jumping out to me right now that are giving me a pretty strong hint about this integrand. I've got something to the fifth right there. And so I'm guessing maybe like that something is going to be what u is. And then I'm looking around at this function and I'm like, oh, look, like 6 and 5 are like one off of each other. Namely, this one's down by 1. I've got 3 going to 2. This 1's not appearing. So like this is looking pretty promising as far as u-substitution goes. But I don't really have the right coefficients, right? Like this should be 6 and this should be 3 if this is the derivative of this, right? Right? Well, let's follow our intuition. Let's go with that gut check here. Let's try letting the inside here be our function u of t. So in particular, I'm going to make this super explicit. I'm going to go u of t is equal to t to the 6th plus t cubed minus 1. That says that du is equal to 6t to the 5th plus 3t squared dt. I went ahead and skipped a step in having the over t and then moving the t right here because that always happens. So I feel like I'm on the right track here. It's just that like we're missing a factor of 3 right here, right? So what do I need to do to like manipulate this expression to get it to appear right here? So I think that one of the right things to do right now, let's just multiply both sides by a half, right? Because like if I have like, or by a third, so if I divide 6 by 3, I get 2. If I divide 3 by 3, I get 1. So like that's going to work out. So let's multiply both sides by a third. There. So I'm going to have a third of du is equal to, let's distribute that here, 2t to the 5th plus t squared dt. And now I've got an expression that appears inside my integrand. So this thing right here, we're gonna consume all the way through the dt as we replace that with a third of du. Do you dig it? Do you dig it? I think while we're working on this stuff having to do with u, we probably should do like the change of variables in this stuff right here. So I'd reference my previous video about this where I was really particular about this. So I'm going to go t equals 1, t equals 0. So now I want to figure out what's u when t is 0 and t is 1, because ultimately I'm going to get a integral in u. I'm going to be in terms of u, so I'm going to change my bounds of integration. So u at 0 is equal to, well, what do we get when we plug in 0 to this expression? -1. And u of 1 is equal to, what do I get when I plug in 1 to this expression? 1 plus 1 minus 1 is 1. So my bounds of integration change from t equals 0 to t equals 1 to u equals 1. U equals minus 1 to u equals 1. So this expression right here is equal to, upon u-substitution, with this being u, and I think that all of this is really important to show your work. Like, you really need to have, like, all of these lines right here in order for the problem to be, like, super complete. So this is the integral from u equals -1 to u equals 1 of u to the 5th, right? Because I have used the inside of this thing to the 5th, times a third of du. So now I've just got a power function. I'm going to go ahead and pull this constant multiple out front using the constant multiple rule. So we'll bring that out front. So I have a third. And then this is equal to power rule. So this is going to go to u to the 6th over 6, evaluated from -1 to 1, which is equal to 1 over 6 minus -1, I guess I'll put my powers in there, to the 6 over 6. Ooh, and that's equal to 0. Because -1 of the 6 is 1. So yeah, so that's u-substitution, another fully worked example. So I think the real takeaway here is hunt for the inside thing, try letting that be u, and then manipulate the du dt relationship. So you're going to have du equals u prime, or sorry, u prime dt. And we're going to look for ways to rescale that so that you actually get the thing that shows up right here. So that willingness to hunt, I think, is going to be pretty key. So thanks for watching, and I hope you have a lovely day.